All right, welcome to classroom. This is ME 43 introduction, right? Yes, so we can start. Yes, this is the introductory material. I already sent you an email last night. Did you get my email? Yes. No. No. You, everybody received my email? So I have sent you 3 files last night. One of them, this one. So I explained this one. The goal of the class and textbooks and operation. And then operation is divided into 3 parts, each 20 minutes each. And grading, term project, and schedule, and lecture. Okay. So it's an overview of two subjects actually, the naval architecture and ocean engineering. Usually in specialized department for shipbuilding, those two are separate class. But as an introduction, I combined them and summarize. So not all of them is covered. As part of 2 topics are covered. Because you are supposed to be not ocean engineering based student. So fundamental or basic terminology. Terminology is very special in this subject. Because of the long history, you will see that. And not recommended for student who has majored in this field. Auditing is okay. Right? So, goal of the ME. So, basic terminology to non-naval architects. So, probably, I hope you can learn, say, 1,000 terminology from this field. Because I remember when I was a student at school, Korean government recommended to learn 1800 Chinese characters for ordinary high school students. So we can expect that kind of 1,000 can be a proper range of learning basics. So course material is made of basically lecture material, the PowerPoint slide set I already sent you last night. So it can be distributed before the classroom. Website will be managed by TAs. So there has been a series of website of this class. You can find many of them. And you can find many material already covered or similarly covered in this semester. So they also include a video, YouTube video of this classroom, because today also TA is recording this Zoom material. So you can watch old classroom. It's boring, like boring, right? But anyway, you can find enough material for this class. Textbook, as I told you that there are 2 books, partly covered each of them. And reference material, the PNA is very thick, heavy textbook. coming from Society of the United States of Naval Architecture and Marine Engineering. And last line is showing you the Korean translation of first book. This one is translated into Korean. Sorry. As a Korean student, you may have a F. Get this. So this is the original book, left-hand side by Harry Benford. And then right-hand side is a translation into Korean language. And then the left-hand side is the second textbook, Elements of Ocean Engineering. And right-hand side is the P&A, the Principles of Naval Architecture, the heavy 3-volume series. So you can find a very deep knowledge of naval architecture. Grading, there will be only one written exam of midterm, only one. And then term project, there will be 3 presentations by yourselves, team. And students probably may have 1 or 2 lectures instead of me, right? And also class discussion led by one of you, not led by myself, led by myself. So that is why I put a higher percentage of grading there, and homework is more. So class operation, 75 minutes is divided into 3 or 20 minutes slots. And this time, 20 minutes. First lecture by one of you, and then myself, 20 minutes of myself. And then the discussion session led by one of you again. That is typical operation of one class. And then also the Zoom is covered every time. Today also I opened the Zoom. Nobody excepting the TA is online now. But sometimes maybe you can have a travel or you can have a sick or other reasons you can participate online. Okay. Student lecture. I will also give you a separate explanation how to prepare your lecture. Also, you can see the videos coming from last year. To see how student lectured instead of me. So PPT from previous semester will be provided in advance, probably by myself. And students need to understand the contents and then explain. And I recommend to find out good video, YouTube video, or other ones can be added to better explain your portion of lecture. And there will be a how to student lecture material will be covered. Previous ones are already in old website. And also I will provide later, including explanation. Term project. Term project including 30% is heavy, right? Large portion. And there has been many previous also materials about previous term project report. So you can also see how the previous student that did their term project. Sea base is kind of air base, but located in sea. Right? Floating air base, you can floating. United States, or before, say, World War II, or after, say, Korean War, or now they have a war, right? Not yet, no, not in these days, but in Middle East, they have a war, right? So that is far away from the United States. When they need a air base because Air Force is very important for fighting. But many reasons, nearby countries do not want to provide land for United States or air base. That's why they try to make a sea floating base for their need. Okay, and then this is about Energy Island. You may see very small picture, but it is a kind of buffet. Wind power, solar power, and then you can't see otherwise, but there is also many other things. Wave power and current power, and also temperature difference. We will learn also about these ideas, but anyway, one team had done this project. And this is Microsoft. You can see the Microsoft symbol there. They had a data center, data storage center under the sea because data center has a very high power and also heat. So cooling is very important for them. High cost. So they had tried to use seawater for the cooling system. And this is coming from France, and they want to make a floating city. Luxury floating city. But there is also storm is coming, and also sometimes there can be a fire. So safety is also important. So this is one of another slide coming from the floating city. And this is similar to floating port. And cranes are there. And this is electric ship in Amsterdam nearby, Hamburg. So you can see the small ship, but nowadays more and more electric ship is coming. Similar to electric car, right? Ship is also moving toward electric city. Especially for the submarine. Submarine, they need to have electricity. Submerged, you cannot run your diesel engine there. Right? That's why they need to have electric power for the submarine. And this one is microplastics in ocean. So how can you clean up? And filling of a large container ship using liquefied natural gas, LNG. And spring 2 years ago, subsea hyperloop. And data center, monitoring, coral reef monitoring using animal, turtle. Right? Last year, there has been many teams, 10 teams. These are titles of those team members of TOM project last year. You can see more on website of 2023. And myself, you can have my email. I also use Gmail nowadays more frequently than KAIST email. And there are two TAs. Anchani first, can you come down and introduce yourself, please?
Hello, I'm Kim Chanya. Nice to meet you.
So where is your office? This building. Good. And supervisor? Benjing Kim is specialized in which area? What is your Are you in PhD course or PhD? What is your title of subject of study? Broad area, not specific. Or what is your supervisor's specialty area? 한국말로? 신체역학 시뮬레이션. 바이오, medical body, bio body simulation. All right, thank you. And then second TA is Kim Soyeon. Come over here.
Hello, my name is Hayan, and I'm also a PhD student in Mechanical Engineering Department, and under same supervisor with Chanyan. So if you need any help, feel free to contact us. Thank you.
So they are at the same laboratory, same supervisor, 6th floor. You can contact through the or we will use SNS, especially Kakao. Kakao is a Korean SNS. I hope you can make your own ID for Kakao next time so that we can make a group talk together. Usually I prefer to use Kakao instead of emailing. Convenient for me. So I will send you the files through Kakao also. Website, there are many websites of this class every year. And also this videotape of this classroom is on YouTube, and link is provided on the website. All right. And myself, I'm retired from KAIST officially, but still working. And my specialty area is CAD, computer aided design. Originally for ship design, computer aided ship design. Was working as a mechanical engineering. I also work for automotive engineering too, automotive design or CAD. And also ISO, the standard. I'm developing standard for CAD systems. So that I studied in University of Michigan as a ship CAD system. And also I had a chance to visit Newcastle in UK, and also all in shipbuilding and naval architecture. So that I started my work in Ocean Research Institute. There is government research laboratory nearby in this town. We can drive to say 15 minutes. So last year we visited this research institute as a tour. I tried to make another trip this semester. CAD/CAM is society. I also make a student. Maybe not today, but I hope you can raise many questions. Otherwise, I will ask you. So please raise many questions at any time. Right. And then that's it for the introduction. Question? No question? Clear? Right. Okay, then let me check your participation or see your names or face. The internet is slow. Separate. Right. Now we have the 20 registered student. We want to see who is Haruta Matsuda. Raise your hands and you can show your face to other students. Haruta Matsuda coming from Japan, right? And then Lloyd Anthony Blackwood, right? Raise your hand, higher, from Jamaica, right? Good, welcome. And then Kim Jin, right? Kim Jin. And say your name or say hello, hi. So otherwise, they cannot see you, right? Oh, guys. Kim Jin from robot specialized area. Okay. 송형규. Right. You see the other students rather than me, right? 송형규, thank you. 심규민 is here. We're here. Say hi. Otherwise, they cannot see. And 정윤성. Sound. Right. It's good. It's okay. And then 최원진. 김기현. 송현우. You turn your face to others. Right? 양희태. Right. 이민근. Hi. 장강민. Right? Turn your face to the background. 조동현. Not here, right? 조동현. Good. Okay. And later then. 조민희. And 조재영. 홍승기. 김정로. Right. 조영준. Hey, good. 한성호. Oh, everybody's here. Hey, that's good. Marie-Céline Duval. Louis or Louis? Louis. Okay. Good. Oh, no PhD student this time. Hey. The other time, there are many PhD students. This time, I don't know how. Good. All right. Question? No question. Then I can move on to next slide set. Overview. Okay. So this is an overview of the first textbook. So we will see in later stage more details. This is just overview. This is the book, the first textbook. Right? And this is a chapter names, titles of the book. All right. See the general arrangement. General arrangement is how can I say this building? This building. How do you expect? How many rooms are there? 100? 50? 200? Any building, right? Because this is connected building. How many buildings are connected? 4 buildings are connected, so 5 buildings. Nuclear, aerospace, mechanical also have a similar. Any building. And then which room is here? 2108. Who made this one this way? There should be a design, right? They locate rooms and toilet and staircase, boilers, and so this kind of thing is you can see there are arranging or locating functions in the space. Very similar. That's why architecture, navy architecture. This building is made of architecture, not architects. Working similar, but location. And hull forms is outer skin of the ship. How can you design the outer skin so that they can override the waves and turning. And static stability is very important. Otherwise, the ship is capsized. Korean student knows about the Sewol ferry accident 10 years ago. Stability is important, but ship is running, not staying, right? So they're divided into static stability and dynamic stability. And resistance and powering, how big should be the engine? Usually the contract, when the shipyard has a contract with the owner or customer, it's a big money, right? Big money to build the ship. One of the key contract item is the speed of the ship. Then the designer should decide how big should be the engine, how many horsepower there to guarantee the speed. But if you had a bigger engine than required, then it costs much higher, and also it is also heavy in terms of weight. Size and weight is heavy. You can think about your car or what can be other. A car is more good for. So big engine is good, but it can be expensive and large, right? So you need to know before making the ship, you need to calculate the resistance power need requirements to guarantee the speed. So it's not easy. Way of estimating will be anyway somehow they do. Similarly to yours, this building, how many rooms? 100. You should have a boiler system and air conditioning system. Nowadays, air conditioning is easier because you can put each room has a separate system. But in old days, there has one big unit somehow in the basic, and then piping to each room, similar to boiler system. Now boiler system also separated. Now each room has a separate unit, simpler. Then anyway, you need to have a estimation, technology. And the propeller, and then engine, especially which engine, which kind of engine, diesel engine, steam engine, nuclear power plant, or wind power, many more. Nowadays, different ways of providing energy, wind powers. And then first strength, the strength of ship. Ship is very slender, we can say slender. Looks like this one. Very long and narrow, usually. And it is, weakest point is bending and breaking into two parts. So you need to know how much forces are on the per body, surface from the weight and running, right? And weight is growing, right? Growing, and speed is coming from petroleum. So that we need to know how much, say, thickness of plate, and the beams and walls, that kind of thing. Materials for construction, usually we are using steel, and nowadays we know different materials, aluminum and also concrete. And in old days, goods was used for yachts is FRP is used for yachts. Structure arrangements is for the small pieces of structure arrangements. This is a whole book, but we will not cover all of them. So what is naval architecture as engineering? Right. Design, construction, maintenance, operation. Yeah. Who is in the Navy guys? Simply, architect for Navy ships. Battle of Actium, it is Caesar. Caesar, know about Julius Caesar. But it is about BC 44. BC means it is before Christ. Before Christ. Right? 40 years of before Christ. Because at that time already they have a big ships like this. And fight each other. So in the Middle East. Marcus Antonius and Octavian adoption by higher and super was crucial in that trouble. At that time, long time ago, 2,000 years ago, the Navy force is very important. Between the war, between countries. So naval architecture was very important at the time. Then, now, probably, right? This old movie, Cleopatra. Have you heard about Cleopatra? Yes. No. Yes, sir. Do you know Cleopatra? No. Some of you know. The Egyptian lady king. And probably Caesar, Kaiser of Roma. Once again, BC equal to Greek from starting Neon, Octavian, Atkinson, Mark Antony. This is a extra. And no, this is a real history. And then probably the story of this history, right? And then the ship is very old, I can say old, right? That's why they have a very specialized terminology. Also, very special. Special means you may not heard about this kind of terminology before, but it is because it is an old one and long used. They has an influence to other engineering fields. Something like airplane. Airplane use very similar terminology. So it's the front of the ship, back of the ship, right hand side and left hand side. You can expect that every time the ship is putting their face to the land, the left hand side is to the left. That's why they say port side. The left hand side is a port side. Every time port side, left hand side to the left. Okay? And the other way, starboard means you can see the star at night, right hand side. Every time they place in this way. And then it is easier for the many ships staying there, right? The traffic. Otherwise, they can track in this way, complicated. Right? So they cooperate in this way. History, I don't know the legal to. Draft means how deep the water surface is there, water line, and then draft is the maximum submersions you can allow it. Otherwise, you may be kept quiet. So then you can say this is the remaining water. We call this flavor. The total is in, say, the depth of water. The water level is important. Right? Next time I bring a water tank, small water tank to show you. If I put, can you swim? Yes, sir. Yes. Swimming. No. So I will have keys on this. Because you cannot see, right? It is, you may say your body is very heavy, so that if you put into the water, you may be submerged. You may expect it. But it is very hard to submerge down to as a human. So when I teach my children how to swim, I ask one time that try to lay down to the bed of the swimming pool. Shallow. Try to lay down. You may try next time when you go to the. It's very hard to lay down, flat down your body, the bed of the swim. So it's not easy to submerge. That's why you can see. Anyway, if I put this as a cup inside in the water, there will be some kind of a submergence somehow in this way. Because this is water, I expected water line should be just almost same as this coffee line. Because water is water. Then if I put, say, heavy material, very heavy, into them, and then it can submerge further, right? That is the way the ship is floating. If you bring a big hole, still plate, Nembi in Korean, Nembi, big hole, and put on the water, it is floating, right? And if I put lots, heavy things, the submergence is increasing, and some point is submerged. The ship is same, still plate, big goal, and cargo is loaded, but the driver want to carry more cargo as a truck, right? Truck, you carry more cargo, then you get more money. So the driver wants to carry many more cargo. That's the way, right? People is trying to. So ship is very similar. So that the safety department arrange that you cannot overload cargo above this one. Then we call this DREPS, road line regulation. So that you need to have a reward for the safety. Question? No question. More definitions. Deck. So it can be a shape. The top most surface, covered surface, call this a deck. Something like a floor, or as a top floor above the building. Top of the building, there's a somehow covered skin out there. Horizon structure floor, my roof, bulkhead, something like this one. Room is divided by vertical wall. The shell is a outer skin. Core surface. There, skin. Inner bottom, floor. You can see the next slide. I should picture. Right. This is a complicated one. Big shape. Made of steel plate. This is a steel plate. One steel plate. You may see the big truck carrying big steel plate. Thick steel plate. Big ships is made of say thickness of 2 centimeters. Thickness of steel plate. Large, say 2 meters, something like that. One piece of plate is very heavy. You cannot handle it. You need a crane. But somehow they collecting and welding together to make a ship. So plating is a plate made of plate, shell, outer shell. There's a bottom. Bottom shell plate, bottom of the shell. There is another button. We call this double button. I'm trying to show you the double button. Another button because in old days, old days, many ships has a pitting rocks somehow near the pole. Titanic. Have you seen the Titanic film? Below Titanic? Yes. No. Come on. Titanic is a very famous film, right? And also very famous disaster. Ship is there. And the ship is hitting iceberg. And the skin is scratched. And hole is there. Water is coming into the ship. And then, see. So there are many cases of bumping in the bottom. Main step. That's why they have another skin, another floor for the safety. If there is a hole, small hole, can be no more clothing inside the ship. That's the way they have a double bottom. Many big ships has a double. Bulkhead. There's a bulkhead. There's a deck. Deck is deck. There are many decks. Many floors in this building, right? Second floor, third floor, ship also floor, deck. And then what else? The deck, right? This is bottom, double bottom. Weight is. So when you see the cargo truck at the backside of the truck, there is a numbers of it written there. Usually, one of them, the most important, is tons of truck they can carry the cargo weight. 1 ton truck is a popular word, and Bongo in Korea. But then there's a 10 ton, 30 ton. Why? Because the driver wants to carry more cargo than allowed. Tendency, there's a tendency. Because of the money. Same as ship. So all the weight, we can say displacement. The total weight, including light ship and weight. And somehow this bottle can get shared. Somehow this is floating somewhere here. So you can expect this much volume of water is displaced by the bottle. Water amount of the submerged body is pressed down. We can say displaced because of the body of water or body of the ship. So we can say this is a displaced water. And the total weight is same as the weight of displaced water. So there is a balance of the total weight and displaced water pressure. Displaced water defy back pressure because they are displaced. Right? So it's a balance of the weight. There is a baseline. Displacement is then the total weight coming from the structure, cargo and including, and then is displaced water pressure plus each other. And then it's divided into cargo weight and like it means something like a bottle weight. Bottle, empty bottle has a weight. Empty ship has a weight. When the shipyard make the first ship before running into the voyage, the new ship, new car, you just this ship from the Hyundai Motors, new car, it has had weight, right? We call this empty ship, empty car, empty bottle has a weight. We call this right? And then cargo. Easy, very simple, but the items is very many. So the calculation is not easy. Payload is same as dead weight, but very small differences. But usually Navy ships use payload. We will explain more in details later. Right. History. Egypt. Khufu, BC, before Christ, 2,500. Long time ago, they already had a ship. This is the ship. This is not this one. This is the look of the museum. This one is the dark one. But still not small. Length is 44 meter. 44 meter is say how can I say, how many floors of building can be a 44 meter? This building, you see that your laboratory is 6th floor. How tall is the height of this, your location of your laboratory? Can you calculate? 6th floor. Height from the net. Somebody can tell. 6th floor. Height. 12 meters. One floor can be 2 meters there. Maybe 3 meters. 3 meters. How tall is it? But there is also height in the cement. Usually, I put 5 meters. Usually, depending on structure. Then, how tall is it? 6th floor is 30 meters. But this one, 8th floor, oh, nice. It's big. 3,000 years ago, they already built such a big ship using wood, not concrete. Where this is? Pyramid, India, Eureka, Archimedes. Have you heard about Archimedes? Yes. No. Archimedes. No. My office is back over this building. Downhill. The building name is Eureka. My office is in the building name of Eureka. M27. So Eureka is coming from Archimedes. He is Archimedes. Well, you see that he is also before Christ 300 years long. Many people are saying he is the first engineer in history. Hydrostatics. We say statics and dynamics. Right? Static stability and dynamic stability. Static hydrostatic. Aerospace. Is there aerospace engineering? Nobody. Aerodynamics. Right? Aerodynamics is for airplane. Aerostatic is a balloon. Balloon is floating, right? Because of hot air. Why? Hot air is lighter than ordinary air. That's why they are floating. Going on. Static means no motion. Static. So you know, you know the story of many of you story about he is trying to measure the weight of this gold crown because many people are saying or guessing that this is not pure gold somehow, right? They want to identify whether this is a pure gold or not, but you cannot rate it. You cannot. There is no weight measuring system at the time because it will be very old. No scale machine. So he tried to use a water measuring, balancing, and somehow he found out. So he shouted as Eureka. That's why the building name is Eureka. Greek history, Phoenician, and Greek in the Middle East, all Middle East, well-known shipbuilders, navigators, ancient Mediterranean world, and there is a terminology coming at that time, right? So we still use Roman and Viking and Tyrrhemes, Roman and Greek. Long ships by Viking. Viking. Have you heard about Viking? Yes. No. No. Everybody know about Viking. Which country is famous of Viking? Which country? Norway? No. Something. Right. Any other answer? Right. Nearby. Yes. Sweden, Denmark. When I visited Denmark some time ago, they say their best year was 1000. 1000. Year 1000. 11th century, 10th century, that was a peak time of Denmark, Kingdom of Denmark, and then gold buildings, top gold buildings are there. So that I asked them, when did you construct this? And that is the center of Viking Kingdom of Denmark. But there are many local Vikings, I guess, Sweden and but areas, because they are located each other nearby, right? In terms of water, ocean, very close. Right? Viking. The Viking ship is a long ship. Why? Because water there, ocean is very heavy there. North Sea, what they call North Sea. North Sea. Oil and gas is very nowadays productive, but North Sea is very heavy, high sea, waves, wind is very flowing. That's why they need to have a very shallow, narrow and long ship. Otherwise, the wave is. Similarly, I will show you later stage. Between Japan and Korea, water is not calm. Right? Between China and Korea is calm. Right? So Japan ships are very narrow and long like this. Oh, okay. The timing. Right. Questions? No questions. Clear. Right? Okay, I'll show you. Schedule. This is the old schedule from last year. Right. We may start with this in this way, right? So at the beginning, this is the first lecture, and today I did show you course also. At the beginning, I only lecture, say 5 weeks, something like that. And then this one is old chart that ocean engineering was covered first, but this time shipbuilding will be naval architecture, right? So starting from say 7th week, you will lecture. But this time also the switch, I will switch the sequence step. One of you lecturing first on my side. And proposal, project proposal. Let me show you. So how to term project will cover the next on Thursday probably, and how to student lecture, and then you have a time to introduce yourself a little bit more than today, and we will make a cacao maybe probably next week, because I know that you can switch class by Monday next week. So after that, we can fix our student members so that we may have a SNS opening, Kakao, homework one, and micro class, project team up, and then we start from project proposal presentation. And at that time, probably this time to 10 teams, you cannot do one day. So we do twice. Midterm exam. And then, so naval architecture is coming later last semester, but this time, this one will be coming first. And then discussion leaded by one of you. Right? Your names is coming out in this way. And project midterm presentation, and there can be probably 1-2 special lecture at the time. Professor Na is coming from Navy officer. So he was talking about the warship design plan. And Professor Ha was coming from shipyard. He worked for Hyundai Heavy Shipyard for more than 30 years. He was specialized in her strength design. So here's a special lecture there. And there was a trip to CRISO, the research laboratory nearby. A car. And final project. In this way. And a similar way. Schedule. Question?
Wait, when is it? When is the exam? Exam.
Exam. When or where?
Yeah, you said it was one exam.
What exam? Which week?
Yes.
It is already announced by the university. There is a midterm exam week.
Oh, sorry, I'm not just being.
You are the first time in KAIST. I should check. But probably near, say, 8th week, something.
Okay, thank you.
Every undergrad courses should be, every exam in this course. Exam.
Which is good.
We met? Yes. Okay. Another question. No, then we can close this earlier then. Right? See you on Thursday.